Okay, so in the last class, we have done certain mathematical problems related to that speed calculations, right? So, any doubt in that one, or have you understood all the concepts? Is there any doubt in those questions? Like we have done the squares of the numbers. Mr. Ashish, can you? Okay then. Okay, thank you. So today, what we have to do, we have to start with the chapter of mathematics. And before that one, I'll give you some 2-3 problems related to the previous class. Let's see how much you can solve. So quickly do these 4 questions. First one is 53 square. Second one is 105 square. Third one is 95 square. And fourth one is 112 square. Do these 4 questions quickly. And those who will complete, raise your hand. Anybody who has solved all the 4 questions? Oh, that's great. Last 1 minute, then I'll discuss the solution. Okay, let's discuss the solutions, then you can cross check your answers. So first one, it is 53 square, and you know this number lies in the range of 30 to 70, so we will take the base as 50, and it is greater than 50 by 3. So here we will write 3 square, and on the left hand side we have to add this difference to 25. So now 3 square is 9, but we have to represent this one as a 2-digit number, so we will write this one as 09, and 25 plus 3, that will be 28. So 2809 is the square of 53. How many of you got this one as correct? Raise your hand. That's great. Okay. Now 105 square. Now you know, I have to either you can solve this by two methods. Either you can take the base of 100, or you also know that it is ending in 5. So if the number is ending in 5, what we have to do? So it is ending in 5. So on the right hand side we have to do 5 square, and here what we have to do? This is 10. So what is the number after 10? After 10 we have the number 11. So we will multiply 10 by 11. So 10 into 11 is 110 and 25. 11025. That is the square of this number. Now similarly 95 square. It is also ending in 5. So 5 square will be 25 over here. And it is 9. So after 9 we have the number 10. So here we will do 9 multiplied by 10. So 9 multiplied by 10 is 90. So 9025 is the square of this number. And 112 square. Now you can take the base of 100 over here. So 112 is 12 greater than 100. So on the right hand side we will do 12 square, and we will add this same 12 to the number itself on the left hand side. So 112 plus 12 we will do, right? So 12 square, you should know 12 square. 12 square is a 3-digit number, and 12 square is 144. So since it is a 3-digit number, but what we will do, we will use only the last 2 digit of this one, and 1 as a carry we will use. So we will write 44 over here, and 1 as a carry we will transfer. So 112 plus 12, that comes out to be 124, plus this carry of 1, that will be 125. So 12544, that is the square of this number. All of you got it? Raise your hand if you got all the 4 of them. If there is there any doubt in the first one? If there is any doubt in the first question, raise your hand. Second question? Third question? Fourth one? Okay, so no doubt. So let's proceed further. So now today we have to start our chapter of maths. So in the 9th class you have studied chapter number 2, which was the polynomials, right? So here also in the 10th class also the chapter number 2, that is also called polynomial. If you see, all the chapters in the 10th class are similar to the 9th class. Like name of the chapter is also same. Like in the 9th class you have studied number system. In the 10th class also there is chapter 1 number 1 real numbers. In the 9th class just chapter number 2 was polynomial. Here also it is polynomial. Then 3 was linear equation, and here also it is linear equation, and so on. The chapter number will be same. There is no difference. Only difference is that the level of the question will get increased, and you will learn some more concepts. Okay. So in the chapter number 2, in the polynomials, in the 9th class you have studied these concepts, like what is a polynomial. I am revising you the 9th class concept, then we will start with the concept of the 10th class. So the starting statement is, what is polynomial you have studied, like degree of polynomial you have studied, then finding the zero of polynomial. Fourth point was long division you have studied, and fifth point was factorization you have studied, and the sixth one was algebraic identities. You have studied these 6 topics, right? In the 10th class we have to again study the degree of polynomial, zero of polynomial, long division, and factorization. All these 4 topics we have to again study, but with a different set of questions. The question will be, you can say, a little bit different from the previous one. 90% of the concept will be same, but a different type of variety of questions will be there over here. So let me revise you. So shall we revise this 4 topics before going to the new one, or shall we start directly with this one? If you want to revise, if you want me to revise these 4 topics, please raise your hand. Okay. So first, the polynomial. So the polynomial, it is denoted by px, and it is basically the when there are n number of terms are separated by plus or minus sign, collection of n number of terms, that is called a polynomial. So in general, the polynomial is denoted by a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2, and so on, and in the last it will go an x to the power 0. Here the names of the different things are that this a1, a0, a2, these are called the coefficients of polynomial, coefficients of the terms. This x is called the variable, and this n minus 1, n minus 2, these are called the exponents. And individually this is called one term, like a0 x power n, this is called one term, a1 x power n minus 1, this is called second term, a2 x power n minus 2, this is called third term. So these are the collection of terms which are separated by plus sign. So these collection of terms are known as polynomials. Now what is the degree of the polynomial? Degree of the polynomial means the highest exponent. The highest exponent of polynomial is called the degree of the polynomial. Like let's say if we have a polynomial, now here the generally we write it as px. You can also write it qx, ax, kx, whatever name you want to give, because this p indicate the name of polynomial and this x indicate the variable which is used in the polynomial. Like you can give any name to polynomial, like I can also write a of k. So a of k indicate that the name of the polynomial is a, and the variable in place of x I am using k as my variable. You can also write q bracket r. Here q will indicate the name and r will indicate the variable which is used. But in general, in most of the cases, you will see that the variable will be used as x and the name will be p, q, r or f, g, h, that will be used. But you can use anything. That's not mandatory that we have to use these of them. Now, so if let's say if this is the px, if it is like this, x plus 5. So it is x plus 5. So here the variable is x. So you can see over here the exponent of x over here, there is no exponent over here, so it means by default it is 1. So exponent of x is 1, and here the with 5 we have no coefficient, no multiplier, so we can write this one as x power 0 also, because x power 0 is also 1. So the variables are x, and here you can see the exponent of x is 1, here you can see the exponent of x is 0. The highest exponent of x is 1. It means the degree of this polynomial is 1. Whatever is the highest exponent, that is called the degree of the polynomial. Similarly, and when the degree of the polynomial is 1, you might remember that the name of the polynomial was linear polynomial. Similarly, when px is equal to, like if it is written like this, x square plus 5x plus 6, here you can see the variable is x and the exponents are different exponents are there, like this one, this exponent is 2, this exponent is 1, and here the exponent is 0. So the highest exponent in this polynomial is 2. So if the highest exponent is 2, it means the degree of this polynomial is 2, and the name of that polynomial was quadratic. Are you getting this? Please raise your hand if you got this concept of degree of the polynomial. Okay, that's great. And similarly, if the degree is 3, their name is cubic, degree is 4, name is biquadratic. You can note down these names For cubic polynomial, the degree is 3, and for biquadratic, the degree is 4. Degree, and one more before one, the constant polynomial, if the degree is 0. Degree 0 means we don't have any variable x, like it will be like this: p of x is equal to 5. We don't have any variable in this polynomial, that's why the degree is 0, and this is called constant polynomial. So in your 10th class, you have to remember only these one: constant, linear, quadratic, cubic, and biquadratic, up to here only. Okay, so shall we proceed further? Now, next thing is the 0 of the polynomial, which we have to find. And the 0 of the polynomial here also, in 10th class also, we have to find the 0 of the polynomial in every case, right? So now, the meaning of the 0 of the polynomial, let's say, first example if we take, if we have p of x is equal to x plus 5. Now p of x is equal to x plus 5, the 0 of the polynomial means what should be the value of this x, so that it makes the value of this polynomial as 0. What we should place in place of x, so that the complete thing will become 0. So what we have to do, to find the 0 of the polynomial, we just have to put px is equal to 0, and px is nothing but x plus 5. So when you put x plus 5 is equal to 0, you will get x equal to minus 5. So x is equal to minus 5 is called the 0 of this polynomial. Why? When you substitute minus 5 again in the polynomial, like you can see, when you substitute x equal to minus 5, minus 5 plus 5, that will become 0. So on substituting x equal to minus 5 in the polynomial, the answer is coming out to be 0. That's why x is equal to minus 5 is called the 0 of this polynomial. So basically, to find the 0 of the polynomial, you just have to equate the polynomial to 0. Like, if I give you p of x is equal to 3 by 2x plus 7, find the 0 of this polynomial. And those who have completed, raise your hand. That's great. Just equate this value to 0 and solve for x. It is just a linear equation. Okay, that's great. So now I am solving this. Check it. To find the 0 of this polynomial, what I will do, first I will put p of x is equal to 0. I will write this statement. And what is p of x? 3 upon 2x plus 7, that is equal to 0. So it is just a linear equation. So what I will do, I will find the value for x. How I will find? First I will take this 7 on the right hand side. So here it is plus 7, it will go on the right, it will become minus 7. Now I will do the cross multiplication. So x will be equal to minus 7 into 2 upon 3. This 2 will go in the numerator, 3 will come in the denominator. So x is equal to minus 14 over 3. So x is equal to minus 14 over 3 is called the 0 of this polynomial. Is that clear? Raise your hand if you got it. That's great. So this was the linear polynomial in which we were finding the 0. Now let's talk about the quadratic polynomial, 0 of the quadratic polynomial. So let's say if we have p of x is equal to x square plus 5x plus 6. This is our polynomial. We have to find the 0. Now here the degree is 2. It means it will have 2 zeros. So first of all, to find the 0 of this polynomial, what we will do, we will substitute this equal to 0. So x square plus 5x plus 6 equal to 0 we will put. Now the most important thing over here is that to solve for this one, we have to factorize this thing. Factorization in the 8th class and in the 9th class also you must have done this type of question. The factorization is called middle term splitting. In middle term splitting, what we have to do, we have to divide this 5x into 2 parts, so that sum should be equal to 5x and product should be equal to the product of the leading coefficient, which is 1 and 6. How many of you know the middle term splitting of quadratic polynomial? Raise your hand. Okay, so I'm explaining this one because this is very important topic, because in every second question you will require this middle term splitting, and this concept will be also used in the chapter number 4 in the quadratic equation also. So understand the concept very carefully, right? So what we have to do, the middle term means the middle term will be always the term which contains the coefficient variable x. This is called the leading term, this is called the middle term, and this is called the constant term. So before doing any operation, you have to make sure that the polynomial or equation is arranged in the standard way. Standard way means the highest exponent will be the first term, then exponent 1 will be the next term, and then the constant number will be the third term, right? Now we have to see that the coefficient of x is plus 5. So we have to divide this plus 5 into 2 parts. Let's say those 2 parts are a and b. So the condition should be that a plus b, the sum of those 2 numbers should be equal to 5, and the product of those 2 numbers should be equal to the product of the leading coefficient 1 and constant number 6. So leading coefficient is 1 and constant number is 6. So 1 into 6. So 1 into 6, that will be equal to 6. So that is the product of the numbers. So you have to think those 2 numbers whose product is equal to 6 and sum is equal to 5. Now here you have to apply a little bit of hit and trial, deep thinking process. So those 2 numbers in which the product is 6 and sum is 5 are nothing but 2 and 3, because when you will do 2 plus 3, that will give you 5, and when you multiply 2 into 3, that will give you 6. So 2 and 3 are those 2 numbers in which we have to divide the 5. So I will write the equation like this now, x square. So in place of 5x, now I will write 2x plus 3x. So this is called the middle term splitting. We have splitted the middle term into 2 parts, satisfying the condition that the sum should be equal to the middle term and product should be equal to the product of the first and the last term. Is that clear? Is that clear till now? Raise your hand. Okay. Now after this step, we just have to do the factorization. So factorization, how we will do the factorization? The first 2 terms you can see, x square plus 2x. Out of these 2 terms, whatever thing we can take as common, we will take as common. So out of x square plus 2x, you can see only x we can take common. So when we will take x as common, we will be left with x plus 2 over here. Now after taking x as common, or make sure that you have to take the highest term as common. So highest variable which we can take common is x. So after taking x as common, we are left with x plus 2. Now whatever bracket you are getting over here, same bracket you should frame on the in these 2 terms also. So instead of taking terms as common, you can directly write x plus 2 over here, so that there will be no confusion. Whatever bracket you are getting over here, same bracket there has to be over here. Now you have to think, out of 3x plus 6, what thing we should take as common, so that we will be left only with x plus 2. So out of 3x plus 6, we should take number 3 as common. If you take 3 as common, you will be left with the x plus 2 in the bracket, and since all the terms are plus, so we will take plus 3 as common. And you can cross verify also. When you multiply 3 with x, you will get 3x again. When you multiply 3 with 2, you will get 6 again. So we have done the factorization now. Now what we will do, now there are two terms. This first term, this is your first term now, and this is your second term. Out of these two terms, you can see x plus 2 can be taken out as common. So when we will take x plus 2 as common, we will be left, from the first term we will be left only with x, and from the second term we will be left only with 3. This is called the factorization. So factors are x plus 2 into x plus 3, and that is equal to 0. Now what we have to do, we just have to one by one we have to equate them to 0. So first we will put x plus 2 equal to 0. So from here we will get x equal to minus 2, and in the second case we will put x plus 3 equal to 0. From here we will get x equal to minus 3. So x equal to minus 2 and x equal to minus 3 are called the zeros of this polynomial. And you can cross check also. When you substitute x equal to minus 2 in the original question again, you will get the answer as 0. That's why it is known as 0 of the polynomial. Let me show you also that thing. Like this was the polynomial x square plus 5x plus 6. If I put minus 2 in place of x, so you can see I am substituting minus 2 in place of x. So the minus 2 square will become 4, this will become minus 10, and this will be 6. So this will be 0. So you can see on substituting minus 2, we are getting answer as 0. That's why minus 2 is called the 0 of the polynomial. Similarly, the minus 3 will also be the 0 of the polynomial. Is this concept clear to you, everybody? Raise your hand. Okay. Now I am giving you one more question on the same type. Now you have to do that question on your own. Do this one. X square plus 7x plus 12 equal to 0. Find the values for x in this case. The same concept is there, the middle term splitting you have to do. That's great. All of you have done? Raise your hand if you have. Okay, so I am solving it. Now you can check. So x square plus 7x plus 12. So we have to split this 7 into two parts, so that sum should be 7 and product should be equal to 12. So those two numbers are plus 3 and plus 4. So we can write this one as x square plus 3x plus 4x plus 12 equal to 0. Then x we can take common, x plus 3, and 4 we can take common, which is x plus 3 equal to 0, and x plus 3 times x plus 4, that is equal to 0. So x is equal to minus 3 and minus 4. These two are called the zeros of this polynomial. Is that clear? Any doubt till now? Mr. Ashish, can you confirm? Okay then, thank you. So now, the first topic in this 10th class, and one more thing, let me revise you that thing also, the long division of the polynomial. This was the finding the zero of the polynomial. Now let me revise you the long division. How many of you already know the long division, like dividing one polynomial by another polynomial? Raise your hand. Okay, so what I am doing, I am solving first question for you, then I will give you the next question, okay? Or you want me to solve the first question, or you want to try on your own? If you want to try on your own, raise your hand. Okay, so this is the question, x cube plus 3x square plus 5x plus 7, we have to divide it by x plus 1, right? So I am solving this question for you. The next question you have to do on your own. So what we will do, first we have to make sure that the polynomial is arranged in the ascending order or descending order, like highest term will be first, then lowest term, and so on. And similarly the divisor is also in the form of x plus 1. So first we will see that here it is x and here it is x cube. So we will multiply x with x square. So x into x square, that will become x cube, and 1 into x square, that will become x square. So x plus 1 basically multiplied by x square. Now we will subtract. So when minus and minus sign, we will change the sign. If it is minus, we will make it plus. If it is plus, we will make it minus. So this will get cancelled out. Now 3x square minus x square, that will become 2x square. And we will copy down this one, plus 5x plus 7 will be copied down. After this you can see, here we have 2x square. So x multiplied by what number will give you 2x square? X multiplied by 2x. So x multiplied by 2x. So x multiplied by 2x, that will give you 2x square. And 1 multiplied by 2x, that will give you 2x. Again subtraction. This will get cancelled out. 5x minus 2x, that will become 3x. And then 7 will be copied down. Now here it is x and here it is 3x. So you already know that we have to multiply x by 3. So when we will multiply x by 3, here we will get 3x, and 1 multiplied by 3, that will be 3. So it will get cancelled out. So 7 minus 3, that will be 4. So here this is called your quotient and this is called as remainder. So this is the question I solved. Now I am giving you one question. Try this on your own, then we will discuss that one. Let's say the question is 3x cube minus 4x square plus 2x plus 1. You have to divide it by x plus 1. Do this question, all of you. 1 minute for you. All of you have solved? Okay, that's great. So I am solving this one. Now here it is x and here it is 3x cube. So first we will multiply x with 2x square, 3x square to get 3x cube, and 1 also multiply by 3x square, that will become 3x square. Subtracting, this will get cancelled out. Now it is minus 4x square and minus 3x square. So minus 4 and minus 3, that will minus 7x square. Now copy down this 2x and 1. Now this is x and this is minus 7x square. So we will multiply x with minus 7x, then only we will get minus 7x square, and 1 multiplied by minus 7x, that will be minus 7x. Now here we have to change the sign again, so it will become plus and this will become plus. This will get cancelled out. So plus 2x plus 7x, that will be 9x plus 1. And now we have to multiply x with 9. So it will be 9x plus 9, subtracting, this will get cancelled out, and 1 minus 9, that will be minus 8. So minus 8 will be the remainder and this will be the quotient. How many of you got it correct? Raise your hand. So shall we proceed further? Mr. Ashish, can you give me the feedback? Shall we proceed further? Is there any doubt in this one? Okay. So now this was the concept. Till now we have covered only the 9th class. This was the things which you have covered in the 9th class. Now let us start with the 10th class topic. So in the 10th class, the first topic is graphical meaning of zero of polynomial. Like in the 9th class, you have done algebraic, like you have found the zero of the polynomial by algebraic method, what we were doing over here. Now in the 10th class, we have to understand what do you mean by graphically the zero of the polynomial. So let's say the graph, let's say if we take the first example, if we have a polynomial of x plus 5, right, or let's say 2x plus 5, this is our polynomial. Now this 2x plus 5, if we plot the graph of this 2x plus 5, like this is, the px can also be written as y is equal to 2x plus 5. We want to draw the graph of this one. Now in the 9th class, you have studied how to draw the graph of this linear equation in two variable. So we require 2 points for this one. So what we will do, let's say this is x and this is y. When we will put x equal to 0, we will get y as 5, and when we will put y is equal to 0, we will get x as minus 5 by 2. So on the graph, this 5 comma 0, 0 comma 5, 0 comma 5 will be over here, x0 y5, and minus 5 by 2 comma 0 will be over here, right? So now if you draw the line passing through these 2 points, so this red color line is called the graph of this polynomial. Now geometrically, graphically, what do we mean by this? You can see this graph, it is intersecting at what point it is intersecting the x-axis? It is intersecting the x-axis at this point. So this point, at whatever point it is intersecting the x-axis, that point is called the zero of the polynomial. Like the point at which it is intersecting the x-axis is minus 5 by 2 comma 0. So minus 5 by 2 is called the 0 of this polynomial, or algebraically you can also solve it. If you put 2x plus 5 equal to 0, so you can say x is equal to minus 5 by 2. And graphically means when you draw the graph of any function, any polynomial, at whatever point it is intersecting the x-axis, those points are called the zeros of the polynomial. So note down this statement: the number of points at which graph is intersecting x-axis are called zero of polynomial. Whatever, so the types of question you will get in this segment will be, the graph will be given to you. By looking at the graph, you have to figure out like at how many points the graph is intersecting the x-axis only the x-axis you have to see. At whatever number of points the graph is intersecting the x-axis, that points are called the zeros of the polynomial. Is that point clear? Raise your hand if this point is clear. Okay, so this was about the linear one. So if we talk about the quadratic one, second one is quadratic. Now the graph of the quadratic, here we don't have to draw the graph of this one, but you should know the graph, or the name of the graph of the quadratic polynomial is parabola. Parabola is basically a U-shaped graph. So if you draw, let's say if we have a polynomial px is equal to x square plus 5x plus 6. In the earlier also we have taken this example, x square plus 5x plus 6, and when we were solving this one, we were getting the factors at x plus 2 and to x plus 3. So here you will get x is equal to minus 2 and minus 3. Those are called the zeros of this one. So if we draw the graph of this one, it will be a U-shaped graph, that is called the parabola, and since there are two zeros, so it will intersect the x-axis at 2 points. So let's say this is minus 3 and this is minus 2. So the graph will be look like this. It will pass like this, and it is a U-shaped graph. This U-shaped graph is called the graph of quadratic polynomial, and the name of this U-shape is parabola. Now you can see the graph which I have drawn, it is intersecting the x-axis at these 2 points, at minus 2 and minus 3. So these minus 2 and minus 3 are called the zeros of the polynomial. So how many zeros this polynomial has? It has 2 zeros, since it is intersecting x-axis at 2 points. Getting this? Are you getting this concept? Please raise your hand. Very good. Now if I draw the graph for another one, let's say if I give you the graph of this thing, this is again the graph of a quadratic polynomial, since it is a U-shaped graph, so it is a graph of a quadratic polynomial. But here you can see that the graph is not intersecting the x-axis, it is only touching the x-axis at 1 point, not intersecting, it is just touching the x-axis at 1 point. So when it is touching the x-axis at 1 point, it means it has only 1 zero. It has 1 zero since it is touching the x-axis at 1 point, that's why. The case number 3 of quadratic one we can take, like this is the graph. Now in this graph which I have drawn, you can see it is neither touching the x-axis nor intersecting the x-axis. it is above the x-axis. So since it is not intersecting or touching the x-axis, we will say it has no zeros. The zero does not exist for this one since it is not intersecting nor touching the x-axis. And we can take the example of this one as, let's say, p of x is equal to, since we have to take a quadratic polynomial which has no zeros. Let's say if I take p of x is equal to x square plus 1. Now this x square plus 1, why I am saying it has no zeros? Basically what we have to do, we have to substitute that value of x which will make the value of this polynomial as 0. Now here it is x square. You can put any value for x. If you put, let's say, if you put x as 1, so 1 square is 1 and 1 plus 1, that will be 2. If you put x as minus 1, so minus 1 square is also 1 and plus 1, that will also give you 2. If you put minus 2, then minus 2 square is 4 plus 1, that is equal to 5. So it means whatever value of x you can put over here, either positive or negative, the square will always convert that into positive, and positive plus positive will become positive. It will, the value of px can never be 0, and since it is never be 0, it means it will have no zeros. The graph will never intersect the x-axis, neither touch the x-axis. So basically you don't have to find the zeros from the graph. You just have in your syllabus, the question will be like this. The graph will be given to you. By looking at the graph, you have to say how many zeros this polynomial has. And in the board examination, 1 mark question will definitely be there from this one. So let's say if I give you this, any random function can be given. Let's say this is the graph. So by looking at this graph, you have to tell me how many zeros it has. So you can, first of all, you have to see the horizontal x-axis. At how many points this graph is intersecting the x-axis, those points are called the zeros of this one. So if you look closely, the points on which it is intersecting only the x-axis, I am saying it again, this is the point on which it is intersecting, this is the point, and this is the point. So only 3 points are there which you can see on which it is intersecting the x-axis. So these are called the zeros. So it has 3 zeros. Are you getting this concept? If you got this concept, raise your hand. Okay. Now I am giving you 4 or 5 questions. So quickly do those questions based on the graph. So first question is like this. This is the graph. These 5 diagrams I have made. Now on these 5 diagrams, quickly calculate how many zeros you can see. That's great. Okay. So now in the first question, you can see I'm solving all the 5, then we will see. The first question, it is intersecting 1, 2, 3 and 4 points. So it has 4 zeros. It is intersecting at only 1 point. It has 1 zero. It is also intersecting at 1 point. It has 1 zero. The fourth question, the graph, it is neither intersecting nor touching. so it has 0 zeros. And the fifth one is also a straight line. It is a horizontal line parallel to x-axis, so it will never intersect the x-axis. So here also it has 0 zeros. 0 zeros means it has no zeros. So how many of you got all the 5 correct? Raise your hand. Okay, that's great. Okay, now let's proceed to the next section of this one. So make sure 1 mark question will definitely be there in the board exam from this one. Only the graph will be given. You have to just calculate how many zeros are there. So next section is relationship between zeros and coefficient of quadratic polynomial. This is the question. This is the like segment, relationship between the zeros and coefficients of quadratic polynomial. And one thing you can see, if there is a quadratic polynomial, the parabola shape, I have given you 3 cases: when there are 2 zeros, when there is 1 zero, and when there is 0 zeros. So the maximum, since the quadratic polynomial has the degree of 2, so maximum 0 it can have 2. Similarly, whatever polynomial you are having, if the degree of that polynomial is n, the maximum zeros it can have n. So make a note of this point also. If a polynomial has degree n, then maximum zeros it can have is also n. If it is a 2-degree polynomial, the maximum 0 it can have is 2. If it is a 4-degree polynomial, the maximum zeros it can have 4. So we can always comment about the maximum. It can have maximum. It is not mandatory that always it will have, but maximum it can have up to n if the degree is n. Like in the quadratic one, if the degree is 2, the maximum zeros can be 2. If the degree is 4, the maximum 0 can be 4. Now coming back to this one, relationship between zeros and coefficients of quadratic polynomial. So first we will define, let's say our quadratic polynomial is ax square plus bx plus c. That is the general form of the quadratic polynomial. Now since the degree is 2 over here, so what we will say that the maximum zeros it can have is 2. And we will denote the zeros, let zeros of px as alpha and beta. These two are the symbols. I think this has been introduced first time. These two are called the Greek symbols. This is called alpha and this is called beta. And one more we will use, that is called gamma. Generally, to denote the zeros of the polynomial, we use these 3 letters: alpha, beta and gamma. Now, if alpha and beta are the zeros of this quadratic polynomial, so what we will write, we can factorize this one. When you will factorize that thing, we will get the alpha and beta. So we can write like this: p of x is equal to k times of x minus alpha into x minus beta. Why we have written in this form? You can see, we can take an example also. Like if we take x square plus 5x plus 6, right, the same example, you know that the zeros of that one are minus 2 and minus 3. So we can write, so alpha and beta, let's say alpha and beta are minus 2 and minus 3, which are the zeros of this quadratic polynomial, which we have already studied. So we can write, we can factorize this one as x minus of minus 2, x minus of minus 3. Then only we will get x plus 2 into x plus 3. So if alpha and beta are the zeros, we can factor the polynomial as x minus alpha and x minus beta. Now you must be thinking that why there is k in the starting, which k is over here. This k can be a multiplier of this one. Multiplier means Like suppose this is x square plus 5x plus 6. If we multiply the complete equation by, let's say, 2, the zeros will not get changed. Only 2 will be the multiplier outside. So that multiplier can be 1, that multiplier can be 2, that multiplier can be 3 also. It will be mentioned in the question. That's why we have considered that k as the multiplier. It can be 1 also. If it is 1, then no need to use this one. If it is other than, then we have to use. So if alpha and beta are the zeros, so we can write this polynomial as k times of x minus alpha into x minus beta. Now from this first and this second, both are equal to px. So what we'll do, we will equate the right hand side of both of them. So we will write like this. On the left hand side we will write ax square plus bx plus c. On the right hand side we will write k times of x minus alpha into x minus beta. Is this clear till now? Raise your hand. The factorization which I have done, x minus alpha into x minus beta, is this clear till now? Please raise your hand if you got it. Okay. So again I am saying it again. This was the polynomial ax square plus bx plus c, and since it is the degree 2, so it means the zeros of the polynomial are alpha and beta, and if zeros are alpha and beta, we can factorize this one as k times of x minus alpha into x minus beta, since alpha and beta are the zeros. This is the general way in which we will write the polynomial in the factored form. Now since both are equal to px, so we will equate both of them. As you can see in the next page I have done, so we have equated both of them, right? Now on the right hand side, let's say this k as it is. If you multiply both the brackets, so if you multiply both the bracket, it will be x square minus beta x minus alpha x plus alpha beta, and then we can write this one as k times of x square. If we take x as common or minus x as common, we will be left with alpha plus beta in the bracket plus alpha beta, and then again multiply with k. So kx square minus k times of alpha plus beta x plus k alpha beta. What I have done, I have just multiplied the right hand side. I have multiplied these two factors, and on the left hand side it is ax square plus bx plus c is there in the left hand side. So only thing, I have just multiplied the right hand side and write it into that form, and the left hand side is as it is. Now what we have to do, we have to compare. Comparing means we have to compare the coefficients of three terms. Here we have three terms. One term is x square, second term is x, and third term is constant. So we will compare the coefficients. So on the right hand side you can see the coefficient of x square is k. On the left hand side the coefficient of x square is a. So we will compare both of them. So we can say a is equal to k. This is the first thing we can get. Second thing, we will compare the coefficient of x now. On the left hand side we have the coefficient of x as b. On the right hand side we have the coefficient of x as minus k times of alpha plus beta. So we can say b is equal to minus k times of alpha plus beta. And the last thing, the constant term, here the constant term is c, and here it is k alpha beta. So we will equate both of them. So c is equal to k alpha beta. So here these three things we are getting by comparing the like terms, like the x square, the coefficient of x, and the constant term. Now from the first thing we know that a is equal to k. So in place of k we can substitute a. So in the second equation we can write b is equal to minus a times of alpha plus beta, and in the third case also we can write a alpha beta. In place of k I have substituted a. So from here we will get, from the second equation, alpha plus beta, this minus a will go in the denominator, is equal to minus b over a. That is the value of alpha plus beta, and from here alpha beta is equal to c upon a. That is the value of alpha beta. So this is the relationship which we have to find finally. Sum of zeros, alpha plus beta is equal to minus b by a, and alpha into beta, that is equal to c by a. This is called the relationship between the zeros. Zeros are alpha and beta, and the coefficients are a, b, c. This is the relationship between. So you have to remember these 2 points in the end. Alpha plus beta is minus b by a, and alpha into beta, that is equal to c by a. These two things you have to keep in mind. Next thing, now it will not always be b upon a. Here in the question, the b was coefficient of x, a was the leading coefficient, and c was the constant term. So in general, you can also write this thing as, in place of b and a, you can also write this thing as alpha plus beta. It was minus b by a. So in place of b, you can write minus coefficient of x divided by coefficient of x square. This is alpha plus beta, and alpha beta is c upon a. C you can write as constant term divided by coefficient of x square. These two things you have to keep in mind. Is this clear till now? Please raise your hand if this is clear till now. Then we can go for the questions then. Okay, that's great. Now when you will solve the question, you will get a clear idea like what we have to do in these types of questions. So let me give you one question. Let's see, it says, example 1, question says find zeros of polynomial x square plus 7x plus 10 and verify the relationship between zeros and coefficient. So the polynomial will be given to you, which is x square plus 7x plus 10. So first part says find the zeros of this polynomial. Second part says verify the relationship between zeros and the coefficient. So finding zero you already know, and the verification which we have learned we have to do. So I'm solving this question for you. Next question you have to solve on your own. So just have a look how we have to proceed in this question. So first thing, find the zeros. Since it is a quadratic one, so we will put equal to 0, and then we will factorize the middle term. This is 7. So 7 should be divided into 2 parts, so that sum should be 7 and product should be equal to 1 into 10, which is 10. So those two numbers are 5 and 2. So we can write this one as 5x plus 2x plus 10. Now you can take x as common. This is the same thing which you have done earlier. 2 times of x plus 5 equal to 0. So factors are x plus 2 into x plus 5. So x will be equal to minus 2 and minus 5. So these are the zeros of this polynomial. The first part is done, which we have already know. Now the main thing is the second part. Verify the relationship between zeros and coefficient. So here the coefficients, if we talk about the coefficient, let's say I am denoting the polynomial as ax square plus bx plus c. So I can say the value of a here is 1, value of B is 7, and value of C is 10. These are the coefficient, and minus 2 and minus 5 are my zeros. So first I will say, and let's say the denoted by alpha. So alpha is equal to minus 2 and beta is equal to minus 5. Now verification, how we have to do verification? First I will say sum of zeros. So alpha plus beta. First two types of verification will be there, product and sum. So alpha plus beta, so which is minus 2 minus 5, which is equal to minus 7. Now minus 7 can also be written as minus 7 over 1, and minus, in place of minus 7 you can say, because 7 was the coefficient of x and 1 is the coefficient of x square, so you can write minus coefficient of x square, or coefficient of x, divided by coefficient of x square. So this is the first verification, that the sum of zeros is equal to minus b by a. Second verification which you have to show is the in terms of product. So product of zeros, so alpha into beta, so minus 2 into minus 5, minus 2 into minus 5, you know that is 10, then 10 can be written as 10 over 1 also. And now you can see it was c by a, alpha into beta is c by a, so in place of 10 you can say 10 is nothing but constant term divided by coefficient of x square. This is the thing which you have to do, find the zeros and show the sum of zeros is nothing but minus coefficient of x over coefficient of x square, and product of zeros as constant term over coefficient of x square. This is called the verification, the relationship between the zeros and the coefficient. Is that clear till now? Please raise your hand if you got this concept. Okay. Now I am giving you the next question. This you have to do on your own. It's a very easy concept, only the zeros you have to find and then you have to do. Solve this one. This is the polynomial x square minus 10x plus 21. Two things you have to do, find zeros and then verify the relationship between zeros and the coefficient. Do this. That's great. Okay, so I'm solving this question. Now you can cross check your solution. So first, I'm directly factorizing this one. So x minus 7 into x minus 3. So zeros are alpha is equal to 7 and beta is equal to 3. All of you are getting 7 and 3 as the zeros. Raise your hand. Okay, that's great. So most of the part is already done. Now only you just have to show the relationship. So first we will show alpha plus beta, that is 7 plus 3, which is equal to 10. And you know alpha plus beta we have to show as minus b upon a. So what we will write? This 10 can be written as minus of minus 10 over 1. And minus 10 is nothing but the coefficient of x, which was b. So we can write this one as minus b over a. And alpha into beta is 7 into 3, which is 21. 21 can be written as 21 over 1, and which is nothing but c upon a. So this was the verification. In place of b and a, you can also write coefficient of x square and coefficient of x, like we have done in the previous question. Is that clear? Shall we proceed? If you want me to proceed, raise your hand. Okay. Now note down the next thing. This was about the finding the zero and verifying the relationship. Second part is this one. Framing of quadratic polynomial when zeros are given. If we are given the zeros of the quadratic polynomial and then we have to frame the quadratic polynomial. So the thing is that if alpha beta are zeros, then quadratic polynomial p of x, that is nothing but k times of x square minus sum of zeros into x plus product of zeros, or you can also write this one as x square minus sum of zeros into x plus product of zeros. That is the only thing you have to keep in mind. This is the same thing which when we were deriving that formula, so we are getting the same thing, right? So x square minus alpha plus beta into x plus alpha beta, so x square minus sum of zeros into x plus product of zeros. And the value of k, mostly in most of the question it will be given to you, like you can take k as 1, you can take k as minus 1 and so on, whatever is given, but the roots will be given to you. So like, let's say if it is given, if zeros are 2 and 3 of a quadratic polynomial, find the quadratic polynomial. So what you will do, first you will say sum of zeros, which is equal to 5, product of zeros, which is equal to 6, and in most of the question when it is not given, you can take k as 1, so you can show let k is equal to 1. So your quadratic polynomial p of x will be equal to x square minus sum of zeros is 5x plus product of zeros, that will be the quadratic polynomial. Or in some cases directly the sum or product can also be given to you. Like, let us start with the question then. Is this concept clear? Raise your hand if it is clear. Okay, it's an easy one, only you have to just substitute the sum and the product. Now let's say if I directly give you sum as minus 5 and product as minus 6, now we have to frame the quadratic equation, quadratic polynomial. So you will say, let's say in all the cases I am considering k as 1 for all the cases right now. So x square minus sum of zeros. Sum of zeros is minus 5 plus product of zeros. So it will become x square plus 5x minus 6. All of you are getting this? If you don't have any doubt till now, please raise your hand. Okay. So I'm giving you 5 questions, so you have to do it. Okay. So basically the first question is, based on this one, find quadratic polynomial with sum and products of zeros given respectively. So in these questions, the sum and product is already given to you. Respectively means first will be sum, second will be the product. Like 1 by 4 comma minus 1. So 1 by 4 comma minus 1 means the first term 1 by 4 indicates the sum, second one indicates the product. These 4 questions. That's great. Very good. That's great. Correct. That's cool. Okay, now I am solving. Now you might be having a sort of doubt in the part 1 and part 3, like how to represent the final answer, because you can see here the zeros are in fractions. In question number 2 and question number 4, the zeros are already in integers, right? So let me solve the first one for you. There can be 2 different answers for this one. The representation might be different. So it is 1 by 4 and minus 1. So basically alpha plus beta is 1 by 4 and alpha beta is minus 1. So you know that and I am taking k as 1 for all of the cases. So p of x is equal to x square minus sum of zeros plus product of zeros. So this will be your, either you can say that this is your answer and this is also correct, but if you want to represent all the, you can, all the coefficients in terms of integers, so what you can do, you can multiply the complete complete polynomial by 4. Why we are multiplying by 4? So that this denominator 4 will get cancelled out. So if you multiply the complete polynomial by 4, you will get this one as 4x square, and when you will multiply this by 4, 1 by 4 into 4, that will become only minus 1x minus 4. So here I have just done what I have done, multiply by 4. So this is also the correct notation. So either you can leave your answer into this form or you can leave your answer into this form, both are correct. So there is no difference between them. Is this concept clear? The representation of the polynomial? Please raise your hand if it is clear. That's great. Similarly, the next, in the same way, the third question was minus 1 by 4 and 1 by 4. So it was minus 1 by 4 and 1 by 4. So it will be x square minus of minus 1 by 4x plus 1 by 4. Now it will be x square plus 1 by 4x plus 1 by 4. Now either you can leave your answer up to here, this is also correct, or you can multiply the complete polynomial by 4. So you will get 4x square plus x plus 1. This is also your polynomial, right? So in the chapter, the exercise 1 was finding the zeros from the graph. This we have done. Second exercise was this one, like in which you have to find the zeros of the quadratic one and compare, verify the relationship. And second one is the framing of the quadratic polynomial when the sum and the zeros are given to you. So this today we have completed these two exercises, right? Now the next one is the division algorithm of the polynomial. So shall we proceed? And note down the homework also. The homework for today from the NCERT, exercise 2.1 and exercise 2.2 you have to do, and all solved examples, because our next class is on Saturday. So before Saturday, these two things should be completed: exercise 2.1, 2.2 and all the solved examples before 2.2. Now the next section is division algorithm. This will be the last section which we will do today. Division algorithm of polynomial. The same concept is there which we have learned in the 9th class also, the long division method. Suppose whenever you are dividing any polynomial, let's say here the polynomial is px, here it is, let's say, gx, here the quotient is qx, and we are getting remainder as rx. So the name of these polynomials is like this. This is called the polynomial which we are dividing, that is called dividend. The polynomial by which we are dividing, that is called divisor. And on the top you already know, that is called quotient, and in the last, that is called the remainder. Now division algorithm means how these four things are related to each other, that is called the division algorithm. So the relationship is that dividend is equal to divisor into quotient plus remainder. Or you can also say like this: P of x is equal to divisor is gx into qx plus rx. This is called the division algorithm. Note it down. And in the division algorithm, all of you have noted this thing? All of you have noted? Please raise your hand. Okay, that's cool. Now, the one thing you might have studied in the 9th class also, that if you talk about the degree of the remainder, what is the relationship the degree of the remainder holds with the divisor? Always remember that the degree of the remainder is always 1 less than the divisor. Like, if we have divisor is of degree n, right? So remainder degree will be less than n. If the divisor is of degree n, then the degree of remainder will always be less than n. And the degree of remainder is greater than or equal to 0 and less than of the divisor. Or you can also note it like this: the degree of remainder will either be 0 or greater than 0, but it will always be less than the divisor. That is called the degree of the remainder. So let's start. The division algorithm is same. So now do this question on your own. 2x power 4 plus 3x cube plus 2x square minus x minus 1. You have to divide this by x minus 1. This is all the types of question will be there which you have done in the 9th class. This is the division algorithm. So solve this question, find the quotient and the remainder. Okay, now I'm solving this question. Just cross check your answer. This was 2x power 4 plus 3x cube plus 2x square minus x minus 1 and by x minus 1. So first we will multiply by 2x cube. So we'll get 2x4, then minus 2x cube we will get, subtracting. This will minus, this will be plus, it will get cancelled out. So 3 plus 2, that will become 5x cube, copying down this 2x square. Now we have to multiply this x with 5x square. So you will get 5x cube, minus 1 multiplied by 5x square, that is minus 5x square, again subtracting. This will get cancelled out. 2x square plus 5x square, that will become 7x square. Then copying down this minus x. Now multiply this x with plus 7x. So that will be 7x square. And minus 1 into 7x, that is minus 7x. Again subtracting. This will get cancelled out. Plus 7 minus x, that will be plus 6x. And copying down the constant minus 1. Now again multiply this x with 6. So we will get 6x and minus 6. Again subtracting. This will get cancelled out, and 6 minus 1, that is equal to 5. So this is our remainder, this is our quotient. How many of you got it right? Raise your hand. Okay, 1, 2, 3 persons. Okay, that's great. Any doubt in this one? Shall we proceed to the next one then, in the front row? Shall we proceed to the next one? Raise your hand. In the front row, is that clear? In the front bench? Okay then. So let's proceed to the next question then. Now this time, if you have to divide, instead of linear, if you have to divide by quadratic, let's say, try this one. X cube plus 3x square, and you have to divide by x square plus 4. Now try this. How many of you done? Okay, now I'm solving this question. Now please concentrate, all of you. So here it is x square and here it is x cube. So we have to multiply x square by what number we should multiply x square to get x cube? We should multiply this by x. So in the top we will write x. So x square into x, that will be x cube. And now it is 4 into x, that will be 4x. So 4x will be not written in below of 3x square, we will write 4x over here. The same term should be written in the accordingly. Now minus, so this will be cancelled out and 4x will also get cancelled out. Now we are left with copied down 3x square and this plus 1 will be copied down. Now this x square will be multiplied with 3 to get 3x square and 4 multiplied by 3, that will become 12. Subtracting 3x square minus 3x square, this will be cancelled out and 1 minus 12, that will be equal to minus 11. So minus 11 is the remainder and x plus 3 is the quotient. Is this clear to you? If it is clear, please raise your hand. Okay, that's great. Let's do one more. Let's say if you have to divide x square plus 3x cube, x power 4 plus 3x cube plus 2x square plus x plus 1. This time let's say we are dividing by x square plus x plus 1. Try this, it's a very good one. And those who will complete, raise your hand. That's great. The last. Okay, now I'm solving it. Please concentrate. So first, this is x power 4 over here, and this is x square. So we have to multiply this by x square to create x power 4. Now all the three terms, x square, x and 1, will get multiplied with this x square. So x square into x square, that will become x power 4. X into x square, that will become x cube. And 1 into x square, that will be x square. Dear students, one thing, I just came to know that you are not following the NCERT book, right? Mr. Ashish has just told me that you are not following the NCERT book, and this chapter polynomial you have studied in the 9th grade itself, right? So that's not an issue because the chapter, the quadratic equation which you are going to study in the 10th grade, it has the same concepts like the middle term splitting, the finding the zeros of the quadratic one, and framing the quadratic equation when sum of zeros and product of zeros are there. So all those concepts are similar one. So you can use all those concepts in chapter number 4 also in the chapter quadratic equations, right? And the thing which is there, like whatever we have studied today, that will be used in the chapter quadratic equation also. So no need to worry. And then because I was not aware that you are not following the NCERT book, I was thinking that you are following the NCERT pattern, but you are following a state board pattern. So that's not an issue. We will cover up that thing also. Okay. So let's finish this question itself. Then we will start with that NCERT booklet with you, right? So is that clear? Please raise your hand. Okay. Sorry from my side, because I was not aware that you are not following the NCERT book. You are following the Manipur book, Manipur board book. So not an issue. So let's finish this chapter, this one, because the same concept will be used in the quadratic equation, and then we will start with the chapters which is there in your booklets, in your textbook. So where we were on this question, where we were x square plus x plus 1, and first we have multiplied by x square, so we were getting x power 4, x cube, and x square. Now just subtracting, so this will get cancelled out. 3x cube minus x cube, that will be 2x cube, and 2x square minus x square, that will be x square, and plus x plus 1 will be copied down. Now x square we have to multiply with 2x, then only we will get 2x cube over here, then x multiplied by 2x, 2x square, and 1 multiplied by 2x, that will be 2x. Subtracting it again, this will get cancelled out. X square minus 2x square, that will be minus x square, x minus 2x, that is minus x, and plus 1 as it is. Now this is x square, here we want minus x square, so we will write minus 1 over here, and minus 1 x square, then plus x into minus 1, that is minus x, and plus 1 into minus 1, that is minus 1. Again changing the sign, plus, plus, and plus. This will get cancelled out, this will get cancelled out, and 1 plus 1, that will be 2. So 2 is the remainder, and this is the quotient. How many of you got this answer? One, two, only 2 persons. Okay. And how many of you were able to solve 50% of this part? Okay, that's great. So it will come with the practice. The more you practice, the more you learn. Because the same concept we are going to use in the quadratic equations also. And because the homework which I have given to you, I was thinking based on the NCERT, but since you are not following the NCERT, so I will go through your book, I will see what homework I can assign it to you, that I will assign it later, that's not an issue. And the next thing is that one puzzle I want to give to you, and the puzzle is that this will work as your homework also. So try to think on that puzzle and then come up with the solution. Like these are the 8 balls, you can see 8 balls are there, and all the balls are of same shape, same size, right? 7 balls are equal in weight, only one ball is heavy. out of these 8 balls, 7 are of similar weight, same weight, only one of the ball is heavy one. You have a weight balance, and weight balance is like this, in which we have 2 pens, one on this side and one on this side. So using this weight balance, you have to figure out which is the heaviest ball out of these one, which is the heavier ball out of these. So question is, what is the minimum number of times you will use this weight balance? What is the minimum number of times you will use this weight balance to find the heavier ball? So we have to use the weight balance minimum number of times, and then we have to figure out which is the heavier ball out of these 8 balls. 7 balls are of similar shape, similar weight, and one of the ball is heavy. This will be your homework for the next class, and do practice those questions which we have done today, like framing of quadratic equation, long division method, and the finding the zeros of the quadratic one by middle term splitting. Those 3 things are very important. Okay, so that's all for today's class. So have a good day, and then we will meet on Saturday. Then we will discuss the other things, right? Okay then, bye.